Have you ever wondered what's at the end of the universe? This is a question that has intrigued, puzzled, and captivated the minds of humans for centuries. The vastness of the universe is almost incomprehensible, a concept so grand and mind-boggling it can be hard to wrap our heads around. Imagine standing on the edge of a cliff, looking out towards the horizon. You see miles and miles of open sky, stretching out as far as the eye can see. Now, multiply that sight by 1 billion, 1 trillion, 1 quadrillion times over. You begin to get a sense of the scale we're dealing with when we talk about the universe. But here's the catch. The universe may not have an end in the traditional sense. Yes, you heard it right. When we think of an end, we usually imagine a boundary, a line in the sand where one thing stops and another begins. But in the case of the universe, such a simple definition might not apply. You see, the universe isn't like a journey with a set destination or a book with a final page. Instead, it's more like an infinite story, constantly unfolding and expanding in ways we can't always predict or understand. So when we ask, what's at the end of the universe, we're not just asking about a physical location. We're also asking about the nature of existence itself. We're delving into the deepest mysteries of the cosmos, exploring the very fabric of space and time. It's a question that pushes the boundaries of our knowledge and understanding. It challenges us to think bigger, to dream wilder, and to explore further than ever before. And while we may not have all the answers yet, the quest for understanding is a journey worth embarking on. So, if the universe doesn't have an end, then what does it have? Imagine an ever-expanding balloon, but no one is blowing air into it. That's one way to envision the concept of our universe. It's a mind-bending idea, isn't it? But that's the beauty of cosmology. It challenges our perceptions and compels us to think beyond our conventional boundaries. Let's delve into the theory of the expanding universe. The concept is deeply rooted in the observations of Edwin Hubble, a renowned astronomer, who in the early 20th century discovered something extraordinary. He observed that galaxies, those enormous congregations of stars, dust, and dark matter, are all moving away from each other. This movement is not random or chaotic, but rather like a well-choreographed cosmic dance. The galaxies are not simply flying off into the void of space, but instead space itself is expanding. This means that every point in the universe is moving away from every other point. Picture again that balloon analogy. The galaxies are like dots on the surface of the balloon. As the balloon expands, the dots move farther away from each other, not because they're traveling across the balloon's surface, but because the surface itself is growing larger. This observation led to a revolutionary idea. The universe is not static, but dynamic, constantly expanding and evolving. It's a concept that has fundamentally reshaped our understanding of the cosmos, giving birth to the Big Bang Theory and the idea that the universe had a definitive beginning. However, this idea also raises a perplexing question, a question that has puzzled scientists and philosophers alike. If the universe is expanding, what is it expanding into? Is there a space beyond space and outside of the universe? Or is the universe infinite, its expansion only adding to its endlessness? These questions challenge our understanding of reality and push the boundaries of human knowledge. They remind us that the universe is a grand mystery, full of wonders and enigmas waiting to be unraveled. But if the universe is expanding, what's it expanding into? That's a question for the ages, and it's one we'll continue to explore. What if I told you our universe might just be one of many? It's a mind-bending proposition, isn't it? But that's exactly what the multiverse theory suggests. This theory, still much in the realm of speculation, posits that what we call the universe might just be one small part of a vastly bigger cosmos, a cosmos teeming with a myriad of other universes. Now imagine each of these universes having its own set of physical laws. Some could be similar to ours, others wildly different. There could be universes where gravity is 10 times stronger, or where time moves backwards. There could be universes where the laws of physics as we know them do not apply at all. It's a concept that challenges our very understanding of reality. But the multiverse theory doesn't stop there. It also introduces the idea of parallel universes and alternate realities. Imagine a universe where you made different choices in your life, a universe where you pursued that dream job, or where you took that trip you always wanted. There could be a universe for every decision you've made, and for every decision you haven't. Each of these universes, according to the theory, exists in its own bubble and operates independently of the others. But they're all part of the same multiverse, like bubbles in a gargantuan cosmic foam. Of course, this is all theoretical. As of now, there's no concrete evidence to support the multiverse theory. It's a concept that exists on the cutting edge of physics, a concept that challenges our understanding of the universe and our place in it. But isn't that the beauty of science? It constantly pushes the boundaries of what we know, continually asking the question, what if? And when it comes to the multiverse theory, that what if leads to an exciting, if somewhat daunting prospect. If there are multiple universes, could we ever reach the end of ours? There's a glow that fills the entire universe, and it's the afterglow of the Big Bang. Picture a cosmic campfire, its embers glowing long after the flames have died down. This is essentially what the cosmic microwave background, or CMB, is. The CMB is a relic from the universe's infancy, a snapshot of the cosmos when it was just about 380,000 years old. But let's put it in simpler terms. Imagine if you could look back in time, way back, almost to the very moment of creation itself. If you could do that, you'd see the CMB. This radiation is everywhere, filling every nook and cranny of the universe. It's like the universe's baby picture, showing us what the cosmos looked like when it was just a wee tot. And here's the kicker. The CMB is the farthest thing we can see in the universe. It provides a kind of edge to our observable universe. But why is this important? Well, the CMB is a treasure trove of information. It tells us about the universe's early conditions, its composition, and its eventual fate. It's like a cosmic time capsule, preserving vital clues about the universe's past, present, and future. However, it's essential to note that the CMB is not a solid boundary. It's not like a wall at the end of the universe that says, sorry folks, nothing to see beyond this point. No, it's more like a fog, a cosmic mist that obscures our view of what lies beyond. This raises an intriguing question. What lies beyond the CMB? Is there more universe out there, hidden behind this cosmic fog? Or is the CMB the true edge of our universe, the boundary beyond which nothing exists? But is this the true edge of our universe, or is there more beyond what we can see? That's a question that continues to tantalize and perplex scientists, a cosmic mystery that we're still trying to unravel. Who knows what secrets the universe still holds for us? Only time, and our relentless quest for knowledge, will tell. So, what lies beyond the edge of the universe? This question has been at the heart of our journey today. We've discussed the concept of an ever-expanding universe, a cosmos that stretches out in all directions, growing larger every second. But what does this mean for the edge of the universe? If the universe is constantly expanding, then the edge is constantly moving, forever out of our reach. We've also delved into the intriguing notion of multiverses. Picture an infinite number of universes, each with its own laws of physics, its own history, its own version of reality. Could our universe simply be one of countless others, bobbing like a cosmic bubble in an endless sea of other realities? Then there's the cosmic microwave background, or CMB. This faint radiation, a relic from the early universe, provides a snapshot of the cosmos roughly 375,000 years after the Big Bang. It's like looking at the universe's baby picture. But as insightful as the CMB is, it only takes us so far in our understanding of the universe's edge. It's a tantalizing glimpse, but not the full picture. Despite our best efforts, the universe keeps a tight hold on its secrets. Our current technology and understanding only allow us to see so far, to comprehend so much. We are like sailors navigating an immense ocean with only the stars and a rudimentary compass. We can chart a course, we can make educated guesses, but there's so much we don't know. Yet, this is what makes the quest for knowledge so exhilarating. Every discovery, every new piece of the puzzle brings us one step closer to understanding our place in the cosmos. The edge of the universe may be elusive, but that won't stop us from reaching for it, from striving to understand the mysteries it holds. While the edge of the universe remains a mystery, the quest for answers continues, propelling our exploration and understanding of the cosmos.